The story of siege weapons is a remarkable narrative of human ingenuity and strategic thinking, driven by the persistent challenges of conflict and fortification. From rudimentary beginnings to the revolutionary impact of gunpowder, the evolution of these destructive tools consistently reshaped warfare and laid the foundational principles for military engineering. Siege warfare was a fundamental aspect of ancient and medieval conflict, often more common than open battles and crucial for acquiring land, resources, and trade routes. The earliest methods involved two main approaches: passive and active sieges. Passive sieges. This involved isolating defenders through circumvallation, encircling a city with walls or ramparts to cut off supplies and reinforcements, aiming to starve them out. This attrition strategy was often a costly and lengthy last resort. Active sieges. These involved direct assaults on fortifications, attempting to breach walls by going through or under them. Early active siege tools were simple but effective. Scaling ladders, used by soldiers to climb walls. However, they were ineffective against walls higher than 10 meters, being unwieldy and prone to collapse. Battering rams. Employed for breaching gates. Ancient Egyptian wall paintings from the 27th century BCE depict soldiers using poles to pry open gates. A 20th century BCE painting clearly shows men using a long beam protected by a mobile hut, marking an early instance of combining a tool with a protective structure. And spades facilitated undermining foundations. The Assyrians transformed siegecraft into a coordinated military science, demonstrating a profound evolution in assault tactics by the 18th century BCE. Their siege trains were integrated forces, including battering rams, siege towers, siege ramps, and sapping techniques. Battering rams. Neo-Assyrian rams, as depicted in 9th century BCE palace paintings, were colossal machines, approximately 5 meters long and 2 to 3 meters high, requiring 6 wheels. They featured a domed turret for archers and wicker shields for crew protection. The battering pole, equipped with a metal blade, hung like a pendulum to pry loose bricks. These rams later evolved to be lighter, needing only 4 wheels. Siege ramps, dating back to the 3rd millennium BCE. These ramps enabled attackers to cross walls and transport heavy battering rams over moats or glacis. Assyrian engineers were highly skilled in building these massive earthworks. Sapping. This involved boring directly through a wall or undermining its foundations. Their sappers dug tunnels and then set support beams on fire to collapse the tunnel and the wall above. This required precision to prevent premature collapse or ineffective undermining. The Assyrian approach marked a significant shift towards specialized military engineering. With tactically integrated siege armies and a dedicated corps of engineers and sappers, this professionalized. An organized approach allowed empires like the Assyrians to reliably overcome fortified positions, fundamentally reshaping ancient conflict and laying the groundwork for future military engineering disciplines. The most significant development in ancient siege warfare was the invention of the catapult, Gastraphetes, belly bow, the first known catapult. Attributed to an unknown craftsman under Greek tyrant Dionysius, the first of Syracuse around 399 BCE, was a large crossbow-like weapon. Torsion power. This mechanism, involving tightly wound ropes, became the foundation for more powerful projectile weapons. Philip II of Macedon utilized arrow-shooting torsion catapults, possibly invented by his chief engineer Polyadus of Thessaly around 340 BCE. Types of catapults. 2 main types evolved from Dionysius's invention. Double-armed ballista, primarily for shooting arrows or bolts, valued for long-range precision, and capable of launching heavy bolts or stones with tremendous force. Single-armed catapult, designed for hurling large objects. Alexander the Great notably deployed stone-throwing torsion catapults, known as lithobloi, during the siege of Helepolis in 334 BCE. Alexander the Great's campaigns showcased highly advanced Hellenistic siege warfare, characterized by sophisticated engineering and tactical innovation. Naval-mounted artillery. Alexander the Great famously fastened catapults and ballistas directly onto ship decks to breach walls. Notably during the Siege of Tyre in 332 BC, causeways. For the Siege of Tyre, Alexander's engineers built a kilometer-long causeway to bring siege towers and battering rams within range of the island city. Helepolis, or takers of cities, Alexander employed massive mobile siege towers. At Tyre, he built 160-foot tall towers on the causeway, equipping them with catapults at the top for counterfire and ballistas at the bottom to hurl rocks. These wooden towers were protected by animal hides against fire. Alexander's army successfully used these machines at the Siege of Gaza as well. Other tactics. Hellenistic siege tactics also included extensive mining operations, scaling walls with ladders and grappling hooks, and the use of incendiary weapons like flaming arrows. The invention of artillery by Dionysius I and the development of torsion-powered weapons marked a fundamental shift. Attackers could now soften up defenses from a distance, reducing direct exposure and making previously impenetrable defenses vulnerable. Introducing long-range bombardment as a primary siege tactic. This sparked a new phase of the offense-defense competition, emphasizing scientific principles in military technology. Alexander's success stemmed from his sophisticated understanding of how to integrate multiple assets: naval power, long-range artillery, and close assault tools, adapting his approach to specific challenges. His campaigns provided a blueprint for future large-scale, technologically advanced siege operations, highlighting the importance of a diverse siege train and skilled engineers. The Romans were renowned for their persistent, strong, and highly effective use of siege engines, contributing significantly to their success in besieging cities. Battering rams. Remaining a common and crucial tool, Roman rams were heavy logs with metal tips used to weaken walls or gates. Soldiers operating them were protected by a movable wooden shelter called a testudo, an evolution of earlier covered ram designs. Siege towers. These tall, wheeled structures, often as high as or taller than city walls, allowed soldiers to launch attacks or drop drawbridges onto fortifications. Constructed of wood, they were covered with non-flammable materials, like iron plating or water, vinegar-soaked animal skins for protection against fire. Julius Caesar reportedly used a 10-story siege tower at you-shay. Artillery refinements. While Greeks laid the foundation, Romans meticulously adapted and refined catapults for widespread military use, notably adding wheels for enhanced maneuverability. Key Roman artillery types included onager, a torsion-powered catapult named after the wild ass due to its powerful kickback. It launched heavy stones, burning pitch, or even dead animals over significant distances. Scorpio, a smaller, more mobile, crossbow-like weapon, firing short. Light iron-tipped arrows or bolts with remarkable accuracy and speed. Operated by one or two soldiers, it was highly effective against infantry or cavalry. Ballista, a large torsion-powered weapon, functioning like a giant crossbow for long-range precision, launching substantial bolts or stones with tremendous force to target fortifications or inflict casualties. The Roman siege strategy was a careful and methodical process, combining military tactics, engineering, and perseverance. A typical approach involved surround and isolate. The city was completely encircled with a wall or fortifications to cut off supplies and reinforcements. Fortified camps were established around the city for soldiers and siege engines. Build siege engines. Necessary equipment, including battering rams, catapults, ballistic ramps, and siege towers, was immediately constructed for the assault. Assault the walls, coordinated attacks were launched. Using siege engines to systematically weaken walls and gates, often combined with surprise attacks, night raids, and diversionary assaults to confuse defenders. Beyond direct assault, Romans extensively used mining to weaken or destroy wall sections. Psychological warfare, such as poisoning water sources and setting fires, also demoralized defenders. Julius Caesar's siege of Alesia in 52 BCE against Vercingetorix is a prime example. Despite being outnumbered, Romans built an extensive 15-kilometer circumvallation, with multiple layers of obstacles to trap besieged forces and expose them to Roman missiles. The consistent success of the Roman military in sieges stemmed from a highly organized and disciplined approach, where siege warfare was a systematic process. Their methodical execution and engineering prowess allowed them to standardize and even mass-produce effective siege engines, integrating them into a comprehensive strategy adaptable to diverse terrains and challenges. The Middle Ages saw significant development in siege technology, particularly catapults. Early medieval engines. These included variations like the mangonel and the traction trebuchet. The traction trebuchet originating in China in the 3rd century BCE and arriving in Europe by the 4th century AD was manpower operated, with soldiers pulling ropes to swing an arm and launch projectiles. It was effective as an anti-infantry weapon and relatively mobile. Counterweight trebuchet, the most iconic and transformative medieval siege engine, first described in the 12th century, harnessed the power of gravity. It used a large, heavy counterweight to swing a long arm, launching projectiles from a sling. This design was more reliable and easier to maintain than torsion-based devices. These machines grew enormous, some exceeding 60 feet in height, capable of throwing stones over 300 pounds more than 300 yards. Their high-trajectory, heavy stone hurling made them exceptionally effective against thick and tall fortifications, initially used to launch projectiles over walls to hit soldiers or litter streets. Later, larger trebuchets battered walls directly for structural breaches. Battering rams. Remaining popular, medieval ram designs increasingly incorporated protective penthouses to shield operators. Wheels were added for mobility and impact force. Constructed from large tree trunks with reinforced metal heads. Some designs even doubled as bridges across moats. Variations like the boar, a drill-like ram with a spiked metal head, gouged out stones from castle walls. Siege towers. These continued to evolve into larger and more elaborate structures, some capable of carrying 200 archers and even smaller catapults. Wheeled, they were pushed against castle walls, allowing attackers to cross via drawbridges. Beyond physical destruction, siege engines played a significant psychological role. Constant bombardment and the imposing sight of massive machines demoralized defenders, often leading to surrender. Attackers also used early forms of biological warfare and psychological intimidation by hurling diseased animal carcasses or human remains into besieged cities to spread fear and disease. The counterweight trebuchet's reliance on gravity, unlike earlier tension or torsion-based catapults, was a pivotal moment. This innovation made trebuchets more reliable, easier to maintain, capable of hurling significantly heavier projectiles over greater distances. This increased destructive power fundamentally changed siege tactics, allowing trebuchets to batter down stone walls or demolish castle walls in a very short time. This tipped the balance of power towards the besieger, making direct wall breaches more viable. The trebuchet's dominance forced a revaluation of defensive architecture, laying the groundwork for changes brought by gunpowder. As sieges became more frequent, especially in timber-scarce regions, medieval strategists adopted prefabrication and improved logistics. Components were increasingly manufactured off-site and transported for rapid assembly, allowing armies to quickly construct massive machines even in resource-poor areas. Saladin's army reportedly assembled for siege engines in 3 days. Richard I transported ready-made components for siege engines by ship from Sicily to Acre. The increasing practice of prefabricating components and transporting them demonstrated growing sophistication in military logistics and project management. This modular design and prefabrication indicated significant advancements in military organization, reflecting a strategic understanding that efficient resource mobilization and rapid deployment of complex machinery were critical for successful campaigns. The arrival of gunpowder, or black powder, in Europe from China in the 1300s, profoundly revolutionized warfare and siegecraft. Gunpowder originated in China with its first recorded military use in the early 13th century, evolving from fire lances and including incendiary compounds and bombs launched by catapults. The first documented use of a cannon in Europe was during the Siege of Algeciras in 1343–44, in their initial decades. Cannons had significant limitations, often doing little against strong castles and fortresses, providing little more than smoke and fire. Early cannons were also cumbersome, typically static and difficult to move. By the 15th century, artillery made its appearance with an impressive impact. This period saw the construction of massive bombards weighing 20 tons or more, specifically designed to batter down walls. Smaller guns were generally referred to as cannons. The greatest advantage of these new gunpowder weapons was their ability to fire heavier projectiles farther, faster, and more frequently than any previous siege weapon. Crucially, they could fire projectiles in a straight line, directly targeting and destroying the bases of high walls, a capability largely absent in earlier arc-firing siege engines. Early cannons were constructed from metal staves hammered together or cast in molds, methods prone to splitting or exploding. Significant manufacturing improvements, such as boring barrels from solid castings, and later using strong central steel tubes reinforced with wrought iron hoops, made cannons much stronger, safer, and capable of being built to larger sizes. Powerful cannons rendered old-fashioned high and thin walls easily demolished. The fall of Constantinople's formidable Theodosian walls in 1453 serves as a stark example. Sultan Mehmed II's 62 cannons breached these walls, which had withstood 20 previous sieges in just 6 weeks. This vulnerability led to a fundamental shift in defensive architecture across Europe. New fortifications specifically designed to withstand gunpowder weapons quickly began to be constructed. Italian architect Leon Battista Alberti theorized about building walls with uneven lines, like the teeth of a saw, and advocated for star-shaped fortresses with low, thick walls. This theoretical shift gave rise to the iconic star fort and bastion systems. The direct fire capability of cannons, allowing them to target wall bases from a distance, led to a new, ritualized siege tactic. This involved constructing trenches parallel to the defenses and zigzag patterns to safely bring guns into effective range. This was a methodical, engineering-heavy approach to positioning guns effectively and securely. The evolution of siege weapons is not just a chronicle of destruction, but a remarkable narrative of human ingenuity, engineering prowess, and strategic thinking. It underscores how pressing societal needs, particularly in conflict, serve as powerful catalysts for profound technological advancements, ultimately reshaping history. The ingenuity in these ancient and medieval machines, and the revolution brought by gunpowder, laid foundational principles for military engineering that persist today.